The sun sets behind Cerro Paranal in the Chilean Atacama Desert. While astronomers get ready to observe with ESO's very large telescope, nature prepares for her own grand display. As night falls over the desert, the southern sky reveals its nocturnal beauty, leaving the spectator in silent amazement. Some people, however, don't just stare at this spectacle. With great skill, they record these unique moments for everyone to see. They are the photographers of the night.
This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory, exploring the ultimate frontier with our host Dr. J, aka Dr. Joe Liske.
Anyone who has been up at night in a remote, high place such as one of ESO's observatories in Chile may have been lucky enough to experience the splendid view of the myriad of stars shining brightly from the heavens. It is both a dream and a challenge for a photographer to capture an image of this incredible view. Today we will focus on 3 ESO staff members who, during their free time, produce outstanding astrophotography. By publishing their results on the internet, they share the enthusiasm for the astonishing wonders of the southern skies with a wider audience. Yuri Beletsky is an ESO fellow and astronomer at the Paranal Observatory. When not observing with the world's most advanced telescope, the VLT, he actively lives out his passion for taking pictures of the southern sky.
I like the night sky, I like stars, and the night sky is so beautiful, you can see millions of stars, and astrophotography is the best way to show the people what actually stars are. So taking this picture, I'm sharing my passion with the people and I'm showing the sky them.
Over time, Yuri has produced many spectacular images of Paranal against the wonderful backdrop of the night sky. A laser beam shooting out of one of the VLT's unit telescopes. The bright constellation of the Southern Cross. The Pipe Nebula, with its picturesque dust lane crossing the Milky Way. Sunlight, reflected by small particles of dust lying in between the planets, causes the faint zodiacal light.
My plans, I would like to take more images, I like to share my passion with other people, I would like to show them the real beauty of the night sky and to show them the real beauty of the nature of Chile and the Earth.
Paranal is an ideal site for astrophotographers, as it offers crystal clear, extremely dark skies with perfect weather conditions on about 320 nights per year. Gerhard Hüdepohl, an electronic engineer at Paranal, knows about the photographic benefits of the VLT's site. Gerhard, who is also a renowned photographer of Chile's landscape, combines the beauty of the Atacama Desert with the shining Milky Way in a unique way.
My favorite type of photography is landscape, and in particular landscape at night, showing the Milky Way, the night sky here of the Atacama Desert. And here in Paranal, then I have the possibility to have the telescopes as a nice foreground and the stars and the night sky as a background.
The bright plane of our Milky Way as it arches above the VLT. An image like this can only be obtained under top-notch stargazing conditions, such as those offered at Paranal. Like Yuri, Gerhard has also produced a spectacular series of images showing the VLT with its laser beam and the night sky.
I'm always trying to show Paranal from new, fresh points of view, different angles, different times of the day, so I'm always thinking about new ideas, so that is my plan for the future.
Astrophotography is very demanding. The photographer has to stay out in the dark and in the chill of the night for many hours. Sometimes it can take several nights of painstaking work in these tough conditions to obtain just one image, and the equipment must always function flawlessly. Stefan Gizar is the head of the optical group at Paranal. His astrophotography benefits from his professional expertise as an optical engineer specializing in telescopes. Stefan's images have been used in several projects for the International Year of Astronomy, as well as in previous ESOcasts.
I take pictures of galaxy and nebula with a telescope, but I also like to take wide field images of the sky with a terrestrial foreground. I like to share with people the beauty of the sky and the universe.
This photographic mosaic of the central parts of our galactic home is just one example of Stefan's work. Taken with an amateur telescope coupled to a CCD camera, the image combines about 1,200 photos for a total exposure time of around 250 hours. Stefan has also produced a spectacular series of time-lapse sequences at the Paranal site. Producing such sequences is quite a challenge, as the images must be taken at regular intervals and all the parameters must match perfectly to obtain the sensation of the moving firmament.
I want to continue imaging galaxy and objects that I have not done yet. And also I'm trying to widen my field by doing 3D pictures, 3D night time-lapse movie, and also big mosaic images of the sky.
There's no doubt that Yuri, Gerhard and Stefan will continue to produce stunning images of the starry skies above Paranal. The wonderful quality of the images is a testament to the splendor of the night sky at ESO's Paranal Observatory. By sharing their work, these three astrophotographers have brought their magnificent view of the southern sky to a wider audience. This is Dr. J, signing off for the ESOcast. Join me again next time for another cosmic adventure.
Cloudy skies may be nice from an artistic point of view, but clouds are an astronomer's nightmare. And while illuminated cities are a nighttime beacon of modern civilization, bright night skies are also a no-go zone for world-class astronomical observations. So, in the pursuit of pristine skies, ESO, the European Southern Observatory, operates its telescopes far beyond Europe, in the remote and arid landscape of the Atacama Desert in Chile. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory, exploring the ultimate frontier with our host Dr. J, aka Dr. Joe Liske.
A top-class site for astronomical observations must meet several criteria. To begin with, of course you need a sky that is free of clouds pretty much all year round. But in addition to that, you also need excellent atmospheric conditions as well as very dry air with as little water vapor content as possible. And this is exactly the kind of environment that you find in the Atacama Desert in Chile.
The Chilean Coast Range. Here, the cold offshore Humboldt Current creates a coastal inversion layer of cool air, which prevents rain clouds from developing. Often, a layer of fog is created, which rapidly disperses in the foothills above the desert. A view from the Paranal Observatory towards the Pacific Ocean clearly shows the top of the cloud layer. In addition to the coastal inversion layer, a region of high pressure in the southeastern Pacific Ocean creates circulating winds, forming an anticyclone, which helps to keep the climate of the Atacama dry. The Andes lie to the east, acting as a natural barrier for clouds coming from this direction. So all the possible paths for moisture to reach the Atacama Desert are literally blocked. This results in extremely dry air and clear blue skies, ideal conditions for astronomical observations.
But we're not done yet with our checklist of ideal observing conditions. In addition to cloudless and dry skies, astronomers need dark sites and unpolluted air in order to make the best observations.
In most places, the world at night is far from being a dark place, and the light pollution caused by modern civilization can easily be spotted. However, light pollution hinders astronomical observations, as it brightens the night sky and makes faint celestial objects undetectable. Only in places that are far from any cities, like some regions in the Atacama Desert, is the night sky pitch black. Furthermore, because Chile's cities are relatively far apart, the air in the Atacama Desert is almost completely free of pollutants and is extraordinarily transparent.
Now, astronomical observations are disturbed by the turbulent motions of pockets of air in the atmosphere. Essentially, this turbulence blurs our images of the night sky. In addition, the atmosphere also absorbs and scatters light. In order to minimize these effects, an observatory should be located in an area with a calm atmosphere above it and on top of a high mountain in order to reduce the amount of atmosphere between your telescope and the stars. Once again, the high-altitude Atacama Desert fits this description perfectly.
The Atacama Desert offers many sites at high altitude, ranging from extended plateau in the Altiplano highlands to high mountaintops close to the Pacific coast. The Chacnantor Plateau, at an altitude of 5,000 meters, offers ideal conditions for observing in the millimeter and submillimeter wavelength domain. This is where ESO, together with its partners, has chosen to construct the Atacama Large Millimeter Submillimeter Array, or ALMA for short. At such high altitudes, there is very little water vapor in the air, and the disturbing effects of the atmosphere are kept to a minimum. Cerro Paranal is an isolated mountain in the Atacama Desert, only 12 kilometers inland from the Pacific coast. This is the home of ESO's Very Large Telescope, which makes good use of Cerro Paranal's approximately 320 cloud-free nights each year. Further inland, within sight of Paranal, another mountain has been identified as an ideal place to conduct astronomical observations, Cerro Armazones. This will be the future site of ESO's Extremely Large Telescope, or the EELT for short.
The Mars-like landscape of the Atacama Desert is really a wonderful gift of nature. Its unique climate makes it a first-class location for ESO's powerful telescopes, so that night after night, astronomers can observe the crystal clear skies. This is Dr. J signing off for the ESOcast. Join me again next time for another cosmic adventure.
Astronomers using ESO's leading exoplanet hunter, HARPS, have today announced more than 50 newly discovered planets around other stars. Among these are many rocky planets not much heavier than the Earth. One of them in particular orbits within the habitable zone around its star. This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory. In this episode of the ESOcast, we take a close look at another major exoplanet discovery from ESO's La Silla Observatory, made thanks to its world-beating planet hunting machine, HARPS. Among the new planets just announced by scientists, 16 are super-Earths, rocky planets up to 10 times as massive as Earth. This is the largest number of such planets ever announced at one time. A planet in orbit causes its star to regularly move backwards and forwards as seen from Earth. This creates a tiny shift of the star's spectrum that can be measured with an extremely sensitive spectrograph such as HARPS. In their quest to find a rocky planet that could harbor life, astronomers are now pushing HARPS even further. They have selected 10 well-studied nearby stars similar to our Sun. Earlier observations showed that these were ideal stars to examine for even less massive planets. After 2 years of work, the team has found 5 light super-Earths around 3 of the stars. These planets are very good candidates for future observations looking for evidence of life. One of the newly found planets, named HD 85512b, orbits inside the habitable zone. This is the narrow area around a star where water can exist in liquid form. Astronomers estimate that liquid water could possibly be present on this planet if it is a rocky world that has more than 50% cloud cover. By looking carefully at the results from the first 8 years of HARPS observations, the team has found that around 40% of stars similar to the Sun harbour at least one planet lighter than Saturn. These new results lead astronomers to believe that they could soon find more super-Earths in the habitable zones of their stars with HARPS. These planets will be great targets for powerful future telescopes to try to study their atmospheres, looking for evidence of life. Thanks to HARPS, the search for another Earth elsewhere in the galaxy is picking up pace.
The Allgäu Public Observatory lies amidst the picturesque landscape of southern Germany. As night falls, a team of scientists and engineers prepares to field test a very cool piece of technology, a laser guide star unit, which will soon be on its way to ESO's Paranal Observatory. This is the ESOcast. Cutting-edge science and life behind the scenes at ESO, the European Southern Observatory, exploring the ultimate frontier with our host, Dr. J, aka Dr. Joe Liska.
Hello and welcome to the ESOcast. Today we are at the Allgäu Public Observatory in southern Germany, because this is where a team of scientists and engineers from ESO is testing a brand new laser guide star unit. What's that, you ask? Let me explain. Now, we've all looked at the night sky and seen the stars twinkling. Now, the stars themselves, of course, don't do any twinkling. The twinkling is caused by turbulence in the Earth's atmosphere. As the starlight crosses the atmosphere, it encounters different pockets of air with different temperature and pressure, which bend the light in different ways, thus causing distortions. In fact, you can see this effect often in broad daylight, whenever you look towards a distant object on the horizon on a hot day. Now, the twinkling is all very pretty and even romantic, but for us astronomers, it's actually a real problem, because it means that our images are blurred and less sharp than they could be if it wasn't for the atmosphere. So, what do we do about it? Essentially, we need a method to cancel out the distortions, in effect, to untwinkle the stars. The way to do it is to bounce the starlight off a mirror that is slightly deformed in exactly the right manner to cancel out the distortions. But how do you know how to deform your mirror?
As ESO's Very Large Telescope observes the sky, a specialized computer can pick a bright star and constantly monitor how it twinkles, deducing the atmospheric conditions above the telescope many hundreds of times a second. The computer then sends commands to a series of devices attached to a mirror in the telescope. bending and flexing it precisely in time with the atmospheric turbulence, cancelling out the distortion in the images.
So for this correction process to work, you need a really bright star in the field of view of your telescope. But bright stars are very few and far between. And remember that the VLT was designed to image only a very small part of the sky at any given time. So for most observations, there just won't be a bright star in the field of view of the VLT. So what do we do now? Well, we make our own. 90 kilometers above our heads, in the upper atmosphere, is a relatively thin layer of sodium. If you fire a powerful laser beam into the sky, you can make these sodium atoms glow, thereby effectively creating an artificial star for the computer to lock onto.
In 2006, ESO installed the Southern Hemisphere's first laser guide star on the VLT. This system greatly improves the telescope's power, meaning that the VLT can make even sharper images than Hubble for certain types of observation. But this existing system has limitations. It can only create one artificial star at once, meaning it can only correct the telescope's vision for a small part of the sky at any one time. It's also very bulky. The equipment has to be kept in a separate laboratory, and the laser beam fed along an optical fibre to the telescope.
Based on the experience obtained with this first system, ESO engineers have been working to build a much improved, new laser guide star unit. So, Domenico, this is it. This is the laser. It's incredibly small. It fits in the back of this small telescope. That's amazing.
Yeah, so this is what we've been working on the R&D for the past 5 years to make a 20-watt laser, very compact and lightweight, that it can be mounted directly on the back of the telescope. So we had to develop fiber lasers first and then develop this kind of laser heads.
So you've just said it, it's a 20-watt laser. That's quite a bit of power, isn't it?
Yeah, this is the power we'll need actually for the next generation laser guide star systems. And right now, for example, in Paranal, we have about 5 watt in the sky. So this is quite a jump in power.
Is the laser beam that comes out at the end of this telescope, is it dangerous? What happens if I put my hand into it?
If you put your hand, you will feel warm, but you don't have to look into the beam.
Okay, so it won't burn my hand, but what about airplanes? Is it dangerous for them?
It's not dangerous for the equipment, so for the airplane. It's dangerous for the eyes of the passengers. And this laser is above the maximum permitted exposure, so we have to avoid that planes cross the beam. In fact, here where we are now, we have obtained a no-fly zone for above us, so we don't have a risk to hit a plane.
The new device is more reliable, easier to maintain, and much smaller. In fact, as we've just seen, the whole unit fits into one small package, which is easy to mount on a launch telescope.
Because it's so much smaller, up to 4 of these lasers can be installed on a single telescope, correcting the VLT's image over a much wider field of view.
So what's happening here in Germany is that our team is testing the new prototype to make sure that it works perfectly before it gets shipped to Paranal. The facilities here at the Allgäu Public Observatory are perfect for this, and what's more, they're only a short drive from ESO headquarters.
Laser guide stars like this will be crucial for the forthcoming European Extremely Large Telescope, which will use adaptive optics routinely. The telescope will be many times the size of today's biggest telescopes, which should mean much sharper image quality. But this great image quality will depend on how well the adaptive optics and the laser guide stars work.
Pioneering new technologies like these will make a big difference to the world's most advanced observatories of the future, especially the EEOT. This is Dr. J, signing off for the ESOcast. Join me again next time for another cosmic adventure.
While we were filming this episode, We got a stark reminder of why ESO's telescopes are located on the mountaintops of northern Chile and not here in the hills of southern Germany. Thankfully, storms like this are not something you ever see at Paranal.